right, so we're kind of bouncing around the book a little bit here, but we're going to go to section 1.2 and look at a process for finding limits using tables. So our two objectives are to literally find a limit using a table. And then the second one is I'm going to introduce some special trig limits that are only findable using a table. So, we talked about, the four methods that you should be able to do most problems with, and a numerical approach is one of those ways that you should be able to analyze it. So the first limit in example 1 here is a rational function. If you plug in 2 like it shows, you automatically get 0 divided by 0, which recall that's an indeterminate form. So that means usually that the limit exists, we just have to do some work to find it. Now, if you know how to factor that and cancel, you can find the limit that way, but not every problem can be done that way. So we're going to try to look at this table in our calculator. So when you turn it on, clear your home screen out, you're going to hit second and then window. You're going to change your independent variable to ask if it's not already set that way. This is a setting that you have to do one time and one time only. So once it's set there, it's good for ever. Okay, and then we are going to put the function right into y1. Make sure to put parentheses separately around the numerator and the denominator so that it works through the rational function correctly. And then second graph is where we view the table. Now let's say you had some values in here that you worked with previously. In order to delete those values, you can just type over them, or you can actually hit the delete button, right, which is right here. Delete, 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 delete. If you like a clear space, you can do that. So all I'm going to do is type in the x values that they are giving me here, one after another, right? So I'm going to type in 1.9, 1.99. Obviously, you can tell this side is calculating the left-hand limit of 2, right? And you can see my y values, right, are getting closer and closer to this, decimal. It looks like 0.25. Okay, then let's go with the table values that are here. Okay, the awkward part of this, right, this table creation is that we are doing it, we're kind of looking at this limit from the outsides in, okay? And then the other issue, right, is that, this is, copied and pasted from our textbook, so it's a horizontal table. And then what we use in our calculator, of course, is a vertical oriented table. So it is a minor detail, but we do have to be able, right, to kind of figure this out. So if we kind of look, in this same way from outsides in, and then like outsides into the middle this way, which is where we're the closest to the number 2, like right here, right? And then we kind of look over here at these values. It does look from both directions, right, that we are approaching the value 0.25 or 1/4, right? So you can fill in these numbers here. You have to do 3 decimals, right, on our exam. So you don't have to write these zeros because we can just truncate it right there. But to here. This is just a further justification, right, that these two numbers here really look close to 0.25. So we're going to say that this limit actually equals 1/4, or you could write down 0.25. And you know that if you factored it, canceled, replugged in the number 2, you would also get 1/4. So that's a good explanation as to what's going on. Okay, let's move to example 2. I'm going to hit y equals to change my function, so clear it. 2 divided by, in parentheses, x minus 5. If you don't have those, it's going to do the wrong function. Okay, and now this table here, right, is blank. So we have to think on the number line what numbers would be really helpful, right? If we have 5 here, and let's say 4, like straight up number line that you used to see on your desk when you were little, right? If we want to approach 5 from the left and from the right, we have to think about decimal values that are very close to 5. So on the left-hand side, right, let's say here's 4.9, and then we want to get closer and closer to the number 5. So we just add in here, right, more 9s and more 9s and more 9s, and then we're getting closer. And then on the opposite side, right, Here, the closest decimal in tenths, right, is 5.1. So let's put that here, and then let's inch closer by adding a couple of leading zeros there so that I am, moving closer to 5 in that direction. And then you should be able to hit y equals second table. And here's where we just had these previous x values, which are now not useful to us anymore because we're looking at these new values here, right? So we're just going to type right over them. 4.9, 4.99, 4.999, and then we'll do the reverse side this way, right? So let's fill these in here and then think about what these values mean. And if we are trending towards a certain number, right? So if I look at these y values that this function is approaching, right? It looks like if I zero in here, these are not very close to each other, right? One is negative 2,000, one is 2,000, right? And if we know what this graph looks like, right, we have a vertical asymptote at 5. If we think back to the original function, the fact that these values are growing on the negative direction, right, means that on the left side of 5, I must have this sort of branch of my rational function. And since these values here on the right-hand side, as you get closer to 5, are getting higher and higher and higher, that must mean, of course, that I have an upward trend, right, at that asymptote. So again, the idea of, are your fingers coming together if you're on this graph? No, they're obviously heading in different directions. These are what, we've sometimes referred to these limits as unbounded. Okay, so we're going to say that this limit does not exist because our left and right hand limits are going different directions. Okay, circle that up. Okay, so now let's go ahead and do a couple of these guys down here. These are some special trig limits that you are supposed to quote unquote memorize. You can use your calculator if it's available. But again, if we plug in 0 right away, right, sine of 0 divided by 0 is indeterminate, right? And so probably that means that there is a limit. Okay, over here, if I do 1 minus cosine of pi divided by pi, what is happening there? 1 minus cosine of 0. No, this is not supposed to be a pi. That's the problem. This is supposed to be the limit as x approaching 0. That's why I'm staring at this weird. So if we do 1 minus cosine of 0 divided by 0, I get the same indeterminate form. Okay, so let's edit that typo together right now. And then let's go ahead and figure this out. So it's indeterminate, right? So I'm going to have to figure out, the left and right hand limits around 0. So think again about your number line. So approaching 0 from the left hand side is going to give me 0.1. Nope, it's negative 0.1, negative 0.01, negative 0.001. And then vice versa on the other side, just those positive values, right? Getting really close to 0. So let's make sure we change our function, sine x, right, divided by x. And then while I'm at it, I guess, let's just type in 1 minus cosine of x. Oh, let's do it with parentheses. 1 minus cosine of x divided by x for the other one, and look at both of them at the same time. Because they're both approaching 0 once we make that change, right? So positive side farther away. So if I look at the sine function, right, which was my blue one, I got to put in the correct values around 0. Okay, it looks like, okay, now these say 1, but if you hover over them with your cursor, you can see at the bottom what that actual value is. this, I don't know why it doesn't just have 0.9 kind of repeating looking, but truthfully it's not. So if I were to transfer these values here, I would get 0.998. I'll try again. 0.999, and it's not okay to put 1 there because technically, right, that value there is 0.999 if I, cursor over it. Okay, I've got kind of the same exact values on the reverse. 0.988 is the other side. Okay, and so if we kind of zero in here, there's a definite trend on the y values, right, that I'm approaching 1. So that is a special limit that we're going to seek to kind of memorize, mainly because it's not factorable, right? Up here, this one, in order to figure out 1/4, we could have done this one analytically. We could have factored it, and we could have got the answer without this mess. However, down here, sine x over x is not a function that reacts in that way. So we really can only analyze it like this. And if we went and looked at this graph, it's really hard to see. What? Hold on. Oh boy. Oh boy. Okay, where are you, Blue? Okay. So what I was trying to do is only turn on the sine x over x graph. This, if I zoom 7, this is what it looks like. Okay, just a normal looking trig function. However, we know it's indeterminate at 0, right? So what that means, and the limit does exist as we can see from the graph, there's a hole at 0. Okay, so it's kind of an interesting function for that reason. Okay, and then let's go back and look at the table, second graph. Oh dear, I got to turn this guy back on so I can see the values. Okay, and now here let's kind of look at what, again, we're running into this scientific notation here, that when I scroll on top of this, right, this really means negative 0.000, I'm going to write too many here, 4 is what that means. So you can see the leading zeros, right, are getting more and more and more. Okay, and then if you go down here, it's just the reverse. It just happens to be positive. And then let's see if that's right. Okay, so this is like, I could have scrolled on these to see a little bit more. This one obviously is a little bit different than what it's showing me too. So I'm putting more than 3 decimals down just so that you can see the apparent idea that we're getting really close to the number 0 here. Okay, and that is what we're looking for. So as we approach 0 on this function, our limit is 1, and we approach 0 on this function, our limit is 0. So there are 2 different values that they trend toward, and I encourage you to take a look at this graph to see what that one looks like too. Okay.